Hi there and welcome to our C5 topic about how much quantitative chemistry. Now we've been doing a lot recently on equilibrium. We're going to be following that up. We've also touched on neutralization reactions, and what we're going to look at today is strong and weak acids. Now you will have obviously done about strong and weak acids in the past, but not really understanding how and why they might be strong or weak, and that's what we're going to look at during today's lesson. Anyway, I'll see you at the end. Bye. Okay, so our objectives for today's lesson on strong and weak acids is by the end of the lesson you should understand how acids can be classified as strong and weak, and what happens during the electrolysis of acids. Okay, so what makes an acid strong and what makes an acid weak? Now, we measure how strong or weak an acid is on the pH scale. Now, what this does is it tells us about the power, which is what the P stands for, of hydrogen. Now, you don't need to know this at this level, but if you are thinking of going on to A level, it's actually a negative log scale. I'll put in how we work it out. pH is equal to the negative log of the concentration of H plus ions. And it's a helpful way there of kind of getting an understanding of this. Now, what this means is that you can have a strong acid or a weak acid. Now, with a strong acid, you have something that has totally ionized. So if we have a look at an example of a strong acid, such as hydrochloric acid, you have HCl, which when you add it into water, it completely ionizes so that all of the hydrogen splits from the chlorine. So you have a hydrogen ion and a chloride ion. Now, in comparison, a weak acid will only partially ionize. Again, you'll have to excuse my equilibrium arrows here, but here we have a weak acid which is ethanoic acid, which will only partially ionize to give some H plus ions and some ethanoate ions. Now, to get an understanding of this, if we were to have 100 particles of each, when you add the hydrochloric acid, there would be 0 of these particles and 100 of these and 100 of these, because it's completely ionized to give those ions. Whereas if you had 100 of the ethanoic acid, there would be 99 of these ions and 1 of these and 1 of these. So you can see that the equilibrium is very heavy in the left hand direction. So it's more to the left on this one. Now, reactions of acids are very similar regardless of whether they are a strong acid or a weak acid. Now, there are general reactions that happen, and when you react an acid, whether it's ethanoic acid or hydrochloric acid, with a metal, you will always produce hydrogen gas. So, for example, if we were to react magnesium with an acid, you would get a magnesium salt plus you'd get hydrogen gas. Now, if you were to react it with a carbonate, such as calcium carbonate, you will always get carbon dioxide being produced, as well as the salt plus water. So, for example, it could be calcium salt, water and carbon dioxide. Now, because you get gases produced with these, the volume of gas can be used to monitor the rate of the reaction. Now, obviously, because we're using a strong acid, you've got more hydrogen ions, you've got more hydrogen ions that can go to form the hydrogen gas. So therefore, you've got a faster reaction. Excuse me. Now, with this one, with the weaker acid, you've got less hydrogen ions, so you're going to make not less, but it's going to be made at a slower rate. Because if we remember the equilibrium laws, if we remove some of the products, as we are when we make the gas, the equilibrium will shift to the right. So it's just worth noting then that because there is a higher concentration of hydrogen ions, you get a faster reaction than you do with the weaker acids. Now, just because you have a faster reaction, it doesn't mean to say that the endpoint won't be the same. You will still get the same volume of gas, of hydrogen gas given off here, as you would in both reactions. It would just take longer for this to happen. So if we have a quick look at what a graph might look like for these reactions, if we've got the time and then the volume of gas going up the side, let's just alter that. Now for the strong acid, you would end up with a graph that looks like this. So this is where it plateaus, is where the reaction ends, whereas with a weaker acid it would go slower, but eventually it would reach that same point. All acids are able to conduct electricity. Now this is because all acids are able to ionize. Now this means that we've got the movement of electrons here and here. Now this means that when we have electrolysis, we're able to form hydrogen gas. Now what happens is the positive hydrogen ions are attracted to the negative electrode. This is called the cathode. So we will always have hydrogen ions going towards the cathode, meaning that's where we get the hydrogen gas. Now, if we've got a strong acid, we're obviously going to make the hydrogen ions a lot quicker than if we were to have a weak acid, because there are more hydrogen ions in the strong acid than there are in the weak acid. Okay, so we have looked at strong and weak acids, where we've incorporated a bit of stuff on equilibrium that we've done before. We've also looked at the ionisation of the acid, so you get full ionisation with a strong acid and partial ionisation with a weak acid. We've looked at the differences in the rates of reaction with different acids, and we've also looked at the electrolysis, where both of them will form hydrogen gas, but again, one of them, the stronger acid, will be quicker than the other. Anyway, I hope you've enjoyed this, and I'll see you next time. Bye bye.